We are going to demonstrate our AMTech 2013 Electronics Lab project. We are from IIITB. We designed a tank maker which we call Tank Press. There are 5 members who worked on this project: Veda, Gayatri, Meghna, Aishwarya and Namrata. There are 4 important components of this project.
The first component is the load sensor. It consists of a 10 kg load cell placed under the global water container. The output is digital. When all the LEDs glow, the weight is maximum, and when none of them glow, the weight is minimum. We integrated this component into our project such that when the water falls below a critical level, an LED glows, indicating a water refill in the global container.
Coming to the push buttons, we have 2 push buttons over here, and this is a circuit regarding this process. One push button represents the input for the large glass and the other push button represents the input for the small glass.
The tank container essentially works on the principle of a servo motor. Depending on the input that is chosen, i.e. small or large, the rotator of the servo motor is open for 0.5 seconds or 3 seconds respectively. The tank then falls into the cup that is placed directly below it until the required amount is reached.
The automated tap requires 12 volts of DC power to work. We have connected a circuit to the automated tap and this transistor acts like a switch. When the transistor is switched on, the automated tap circuit is closed and the tap lets water flow. So the transistor is kept on for 18 and 47 respectively for small and large glass.
Hi everyone, we are now going to present our electronics project. Our team members are Anisha, Sweta, Soumya, Murali and Abhiram. We actually came up with a crazy idea of implementing interesting and very famous Snakes and Ladders game. The challenges in our project are digital dice, 5x5 board, photoresistors giving input to the board, 7-segment display which displays how many times the dice has been rolled. As we have implemented this game only for one player, we would like to challenge the player to finish it within 15 moves.
Coming to the dice, there are 2 push buttons and 7 LEDs which make the dice for this game. When the first button is pushed, a random number gets generated and the LEDs glow according to it in the shape of the numbers as appears on the dice. When the second one is pressed, the LEDs stop glowing and the number gets updated in the 7-segment display.
As mentioned, we worked on LDRs to detect the number on the dice. As we followed the pattern of numbers on the dice, the pattern of numbers are as follows. For the 1, the middle LED glows. For 2, the 2 corner of LEDs glows. For 6, all the ones except the middle one glows, and given as input to the board.
Coming to the board, this is a 5x5 square board containing 25 cells. This board is controlled by a microcontroller. As mentioned, the random number generated in dice is detected by the LDR sensors and sends the information to the microcontroller which controls the Snakes and Ladder board. Depending upon the dice value, we update the present position of the player on board. We represent the position of a player by glowing an LED at the corresponding cell.
The main idea underlying the glowing of the LEDs is that the whole board is controlled using 10 pins, 5 for rows and 5 for columns. Every LED is connected to the output of the AND gate, whose inputs are corresponding row and column of the LED. Therefore, the LED glows only when its row and column are digital high. Whenever there is a snake or the ladder, the position of the player gets updated. As seen, there is a snake from 14 to 5. Therefore, as soon as the player reaches 14, he goes down to 5. Finally, when the counter exceeds 15 or the player completes the game ends and the LEDs start glowing in this way.
It is a solar-powered traffic control system. We have a solar panel, a rechargeable battery for storing the solar energy, a 20x4 LED display showing the countdown timer, and a 4-sided traffic.
The aim was to make the traffic system efficient and run the system purely on solar energy. This can be done by harnessing direct solar energy using the 4-watt solar panel during the day and by storing the solar energy in a rechargeable battery and driving power from it at night.
The Arduino microcontroller was programmed to control the timings of red, yellow and green lights. The clock for each of these lights was set to certain time such that one whole cycle that each road gets green light finishes in 200 seconds. So accordingly, the green light for the particular road lasts for 45 seconds followed by the yellow light for 5 seconds, leaving 150 seconds for the red light.
The 20x4 LCD display was used to display the countdown time for the traffic lights. It displays messages: stop for the red light as it counts down from 150, go for green as it counts down from 45, and get ready for the yellow light as it counts down for 5 seconds.
Regarding the connections, 2 Arduino Uno boards were used for connections with 13 digital pins each. One Arduino board was used to display the traffic lights, that is red, yellow and green, and other Arduino board we used it for LCD display to display the countdown timer. We also soldered the LEDs to solve the problems of loose connections.
The group members involved are Lasya, Meghna, Cheryl, Ravali, Trisha and Shruti.
We batch of 4 guys did this project, namely Prudvi, Arvind, Satvik and Niklesh. We used the components Arduino based robot, transmitter and receiver which has operating frequency of 434 MHz, ultrasonic sensors, extra Arduino board and an accelerometer. In this project, a person is blindfolded and is expected to control the robot's movements in a maze. He relies on the output of the ultrasonic sensors that guide him.
The electrical component used for this is accelerometer. Its chip number is ADXL335. It gives 3 analog inputs to the microcontroller which correspond to 3 axes, by which it can be decided which direction the robot is intended to move.
The communication part consists of the transmitter and a receiver which are on the base station and the robot respectively. The 3 inputs that are received from the accelerometer are encoded into 4 bits of information that will correspond to the movement in each direction. This information will be transmitted to the robot, when the receiver on the robot receives the information and decodes it. Based on the information received, the robot moves accordingly.
To test the robot, we have built mazes, in which a blindfolded person is supposed to maneuver it. He is given the accelerometer. If the robot encounters an obstacle in its path, the ultrasonic sensors detect it and a low-pitched beep is heard. If it turns right or left without any obstacle in its path, then it gives a high-pitched sound.
Now we'll see how it works. Forward, obstacle at front, stops, obstacle to the right, left, forward, obstacle at front, stops, right, forward, obstacle to the left, right, forward, obstacle at front, obstacle to the right, left, forward, obstacle at front, stops, obstacle to the left, right, forward, obstacle at front, stops, right, forward, obstacle at front, obstacle to the right, left, forward, camera ahead, so obstacle at front, stops.
Hello everybody, welcome to our Relab Project 2014, which is facial recognition using OpenCV and Arduino microcontroller. Now facial recognition we are doing using OpenCV, which works on C++ code. What it does is it takes screenshots of a person's face, stores it into a file, and this file is passed to the Arduino microcontroller after recognition, which will display the final name of the person recognized. However, Arduino microcontroller itself does not have a file I/O capability, so we had to use a Java-based IDE known as processing, which helped feed the data from the file into the Arduino microcontroller so that it could be displayed. How it does this is it passes the data read from the text file to the serial monitor of the Arduino microcontroller, which displays the name of the recognized person finally on an LCD display.
This is the circuit for the LCD display using the Arduino microcontroller. We're using a JHD20x4A LCD display. These pins act as the input to the LCD display, which correspond to these pins, and this input is from the output of the code, whereas these pins correspond to the power and the backlighting of the LCD display corresponding to these pins. The potentiometer used here is to control the contrast of the LCD display.
You have two windows on the screen. The one on the left is the terminal in which we are going to run our face recognition code, The one on the right is a small window which is a interface between our OpenCV C++ code and our Arduino LCD display. Now we're going to be running our code. What has come on the right is the GUI of the face recognition system. And now as we add a person, we have to enter the name on the left of the terminal. As soon as we enter the name, the face, as you can see on the terminal, the faces are being saved into a file. We add up to 10 faces for each person, and now the next person is going to be added. The name of the second person is being entered. The faces for the second person are being recorded. Now we're going to add another person. The name of the third person is being written. Again, we save about 10 images for the third person. The fourth person is entering the name. And now we start the face recognition. And as we click on the screen, the face recognition starts. As you can see on the left side, we have the face recognition starting, and on the very right we have a green color box which is showing which person it has matched with, and on the top of the GUI we have how much percentage it match has happened. This output goes to our LCD display, and now our second person is going to be detected. As you can see, again a green box is made on the person who's been detected. As you can see, again the next person too is detected. The name is printed on the terminal on the left hand side, and the output is going to the LCD display. And now we stop our code. And this system can be used as an automated attendance system, as we just put it at the entrance of any classroom. As the student enters, he is just detected, and all we have to do is just run the same code at the very end of the class, where it recognizes when a person just moves out.